is multiplying and dividing rational expressions. So basically, you guys have learned how to multiply and divide fractions, normal fractions, with numbers. And now we're going to learn how to multiply and divide rational functions, which are fractions that have like polynomials on the top and polynomials on the bottom. So we're going to be factoring and reducing. So it says we simplify rational expressions in the same way that we simplify easy fractions. So for instance, if you were reducing 15 over 24, you could break the numerator into their common factors. So what is in common with 15 and 24? 3, right? So we think about this in our head as being 3 times 5 over 3 times 8, and we say, oh, they're both divisible by 3, so I'm going to reduce it down by dividing by 3 and dividing by 3, and then we get 5/8, right? So that's what we're going to do with these. So we're going to try to take our rational expressions, which are basically like things like 5 over x squared minus 9 over x plus 3, right? We're going to take those things and we're going to factor them and reduce out any common factors, okay? So the first one, I have 10x the 8th over 6x the 4th. Okay, so let's think about just those numbers, the 10 and the 6. What do the 10 and the 6 have in common? 2. So what we're thinking of this as is 2 times 5 over 2 times 3. And then our x's, we have 8 x's along the top, and we have 4 x's along the bottom. Well, we've done this. We've done this in an early chapter, like chapter 5, where we reduced out x the 8th over x the 5th. Do you guys remember we would think, okay, we have 8 x's, and we have 4 x's, and we're dividing by x, right? And so 4 of them cancel on the top and bottom. Do you guys remember the rule that we ended up learning? Like we have 8 on top and 4 on the bottom. How did we know how many were on the bottom? Yeah, we subtracted those exponents. Do you guys all remember that? So this ends up being x to the 4th. And our 2 and our 2 reduce out. So it reduces out to 5x to the 4th all over 3. So you're just canceling your common factors. That's all we're doing. So the next one is a little bit tricky for students at first because they always want to cancel those x squareds and they want to cancel the x's and so on. That's not what we're doing. So let's think about numbers, okay? So if I had like 2 plus 3 over 2 plus 4, tell me what the result is there. It is what over what? 5 over 6. We all understand that concept, correct? We understand that we have to add these together and get 5 all over 6. Is it the same as if I canceled? So can I just cancel the 2's? No, 3/4 is not the same as 5 over 6. We all understand that concept. Okay, so for the same reasoning, when we have something like x squared plus x minus 2 over x squared plus 2x minus 3, we cannot cancel these x squareds, okay? Everybody always tries to do that on the test, not everybody, but I always have like 5 students every test that try to do that. Okay, we're not going to be those students, correct? Yes, yes ma'am. All right, so we know that we have to factor things. We have to factor in order to have like something being multiplied that reduces. That's what we're doing. So we're going to factor the top in its 2 sets of parentheses, and we're going to factor the bottom in its 2 sets of parentheses. I told you factoring would never go away for the rest of Algebra 2. Sometimes people don't believe me. They're like, oh, it's fine. I don't need to know this. All right, so I'm going to have x and x, and I'm going to need a 2 and a 1 in order to multiply to be 2. They need to be negative 2, so I need the opposite signs. So let's look at our outer and inner swoops. So we have 2x and 1x. We want it to combine to be positive 1x. So we're going to do the negative 1 and the positive 2. Perfect. So on the bottom, I'm going to have x and x. And I know I need 3 and 1. And again, I can think about my outer and inner terms. So outer and inner need to combine to be positive 2. So I'm going to have a positive 3, but a negative 1, right? Here's my hint. If you can't figure out how to factor it, but you've gotten at least the top, if you're like, oh, the top part factored, probably one of those factors is going to be the same in this chapter. Do you guys understand? Because we're probably going to cancel them, right? So if you're like, I can't factor the bottom, what's the problem? Then maybe you should try x minus 1 as 1 apart, okay? That will help on those more complicated factoring ones. All right, so we have x minus 1 in common. That's all being multiplied by x plus 2. It's all being multiplied by x plus 3. So we can cancel that out because now it's like these ones where we had something multiplied, right? 3 times 5 over 3 times 8. So when we cancel it, we end up with x plus 2 over x plus 3. And then we're done. We do not cancel those x's. Again, do we understand why we don't cancel the x's? Yeah. All right, so let's factor the next one. So on the top, we have a GCF that we can pull out. So we can pull out an x. And when we do, we get 4 minus x. On the bottom, we have x minus 4, and we have x plus 2. Now the factor on top and bottom do not look the same, right? I have 4 minus x and I have x minus 4, which they're similar, but they're not exactly the same. Any ideas? Yep, that's right. So let's take out a -1 from the top one. So I'm going to pull out a -1, and when I do you see how I'd have -4 plus x like that if I pulled out a -1? So this one right here. If I pull out a -1, I have -4 plus x. Well, isn't that the same as x plus 4? Or, yeah, oh, x minus 4. Darn. X minus 4. Eric got a bonus point. He caught me. All right, and then on the bottom, I have x plus 2. So now can we cancel? Yeah, we can cancel that x minus 4, right? So our final answer is going to be -x on top over x plus 2. Done. Okay, so if you recognize that two terms are the opposite of each other, like for instance, if you had 5 minus x on top and x minus 5 on the bottom, we don't have to do that inner step. We can say, oh, those are going to cancel, but what am I going to be left with? What do I put on top? A -1, right? So when those cancel, make sure you write -1. Okay, so you can kind of shortcut that process. All right. So it says you can also multiply rational expressions just like fractions. So if you remember way back when you first learned fractions, think about things like 27 over 16 and 24 over 81. Chris, you with me? So Chris, would you multiply 27 times 24 over 16 times 81? Would you do all of that? No. There's an easier way, right? What would you do? Yeah, you try to simplify first, right? So we're going to try to simplify. So any common factor that's on the top can simplify with any common factor on the bottom. So maybe they don't have, like 27 and 16, those don't have anything in common there. But remember, we would be multiplying everything across the top. We'd have 27 times 24 on top, and then 16 times 81 on the bottom. So really anything that's on the top can cancel with anything that's on the bottom. So let's look through. How about the 16 and 24? Can those reduce out? Yeah, 4 can go into it. Anything bigger? 8, yeah. So we can make this 3 and 2. And then the 27 and 81, that might be a little bit harder. 3 goes into it, definitely. So 9 goes into it, yeah. So I could have 9 and 3. So right now I have 3 over 2 times 3 over 9. Can I go any further? Yeah, 3 and 9. So make 1 and 3. So right now I have 3 over 2 times 1 over 3. Can I go even further? How about this 3 and the 3, right? 1 and 1. This all simplifies down to 1/2. That's it. So did we want to do 27 times 24 over 16 times 81? No, I don't know what 27 times 24 is. I would have to use a calculator. Even me, as a math teacher, I would need a calculator. So don't overcomplicate things. Don't multiply things out if you don't have to. And this happens also every year on the test where people will get things like, I don't know, things like this. I know it says division in here. So imagine flipping it, and then they're foiling out like this one times this one. They're multiplying that all out. That's crazy. Don't do that. Like that takes a really long time, and it's very complicated. So we're not going to do that. We're going to know to always simplify first.
Can you do that problem?
Yeah, we're going to, yeah. Okay, so number 1. So this one, these are all like monomials. They're all like grouped together, right? We don't have any pluses or minuses. So we could simplify everything that's here, and we can simplify everything that's here. Or really, you could reduce anything that's on top with anything on bottom. But let's start with the red circle and then the blue circle. So in my red circle, I would have 3 and a 2. So 3 over 2. How about the x's? What do those reduce down to? X squared. And the y's? Y to the 4th on the bottom, right? So you could say y to the -4, but I always put it in the correct location and just make it positive. All right, how about the blue one? So we still have the 10 and the 9. How about our x's? X on top. and y on the bottom, right? So let's start reducing out these numbers. So my 3 and my 9 can reduce to 1 and a 3. And the 10 and the 2 can reduce to a 5 and a 1. So right now I have 5, and I have x squared times x, so I'm going to write x cubed over 3, and I have y to the 4th times y, which is y to the 5th. So quick check, can it go down any further? No, because I don't have any x's on top and bottom or y's on top and bottom, so I am done. That's your answer. So now let's try the next one. So these ones are different. These ones are not monomials. They have pluses and minuses and so on. So this is where you have to be careful, and you can't do those things we were talking about with like x over x squared reduces to 1 over x, right? Because that x is attached to the plus 5, and the x squared is attached to the minus 9. So we have to factor all of these things. So on the first set, when I factor it, I'm going to have x minus 3, and the bottom part does factor. Close. How do we factor this? So, yeah, it has a GCF. So we have that 4, right? So we're going to pull out the 4, and we're going to have x plus 5 like that. So those are the ones that sometimes people overlook because they're like, oh, it's just x the first, it's not going to factor. But actually, there's a GCF. So look for those GCFs. All right, and then the next one, so I have x plus 5, and then on the bottom I have x squared minus 9, which we know factors into what?
X minus 3 squared.
X plus 3 and x minus 3. Be careful, difference of two squares, right? That way we don't have that middle term. It's like 0x in the middle. Now we're ready to start reducing. That's the fun part. I always like canceling lots of things. All right, so we have x minus 3 and x minus 3. Those cancel. We have x plus 5 and x plus 5. Those cancel. Anything else? No, I've canceled everything on the top. Do I write 0? No, I write 1, just like fractions, right? Just like when you multiply fractions, if everything canceled on top, we write a 1. So I have 1 over 4 times x plus 3. And I would just leave it like that. You could write 1 over 4x plus 12.
Is that not right?
I usually just leave it in its factored form just in case you see any other factors that can reduce out. Okay, that one is okay. This next one's a little bit harder. So let's see if we can do it. So I have 1 minus x to the 4th. That's the difference of two squares, right? It might bother some of you guys. You might not like seeing 1 minus x to the 4th. So you might think, oh, I can pull out a negative 1, and then I could have x to the 4th minus 1. You can do that if you want to, if it bothers you. Or you can keep it as 1 minus x to the 4th and say, oh, that's 1 plus x squared times 1 minus x squared, right? The difference of two squares. That 1 minus x squared will go further, but we'll do that on the next step. All right, so then I have x to the 4th minus x. Well, that has a GCF, so I pull out an x. And I have x cubed minus 1. Oh, man. And then I have x squared on top. And on the bottom, I have x to the 4th plus 2x squared plus 1. So that's going to factor into x squared plus 1 times x squared plus 1. Do you guys see how it's, if you FOIL it out, like you're going to have x squared times x squared makes x to the 4th. My outer and inner are 1x squared and 1x squared, which combine to 2x squared, and the 1 and the 1 make 1. So we're kind of getting there. Yeah, that 1 plus x squared and the x squared plus 1 go away. How about the x squared and the x? Yeah, you can cancel them, but you're going to have what left on the top? One of those x's, right? So I'm going to cancel, and I'm going to have an x. It's always hard to cancel x's. Sometimes I circle it and cancel. All right. So the bottom, well, the top I have 1 minus x squared. How does that factor? 1 minus x squared is 1 plus x times 1 minus x. It's the difference of two squares. So this one's testing to see if you really remember your factoring. Do you guys remember when you have x cubed minus 1? It's the binomial and trinomial, the difference of two cubes. SOAP, do you guys remember SOAP? So we want to think about what's being cubed. We have the x is being cubed and the 1 is being cubed. That's like our a and our b in the formula, if you use the formula. So in the first parentheses, I drop my cube. So I'm going to have x minus 1. And in the second parenthesis, I have 3 spots. In the first spot, I square the first item. So x times x makes x squared. In the last spot, I square the last item. 1 times 1 is 1. In the middle spot, I multiply the two together. 1 times x is 1x. And my signs in the end are SOAP. Same, opposite, always positive. So we have the same as what we had originally. We have opposite what we had originally. And we have plus at the end. So this factors into x minus 1 times x squared plus x plus 1. And then on the next one, I have x, and then I do x squared plus 1. So is there anything else that reduces out? Yeah, the x minus 1 and the 1 minus x. And what do I write when I reduce those out? Yeah, that's where I get that negative 1. So I cancel, and I'm going to gain a negative 1 through that. So your final form is negative 1 times 1 plus x times x all over x squared plus x plus 1 times x squared plus 1. Not very simplified, is it? They aren't that hard on your homework. I don't do any cubes on your homework. Does that make you feel better? Or are you guys like, oh, sum of difference of cubes, oh no. All right, so let's talk about dividing. So we know that if we have two fractions divided, if I had 3/4 divided by 5/6, what do I do? Yeah, I like multiply by the reciprocal. Which one? The first one? The second one, right? I do 3/4 times 6/5, right? Right? Do we all remember that? So that's what we're going to do here. So when we have a division sign, we're going to rewrite it so we see multiplication. So I'm going to have 5x to the 4th over 8x squared y squared times, and I'm going to put 8y to the 5th over 15. Okay, and then I start reducing out, just like before. So like the 5 and the 15 reduce, and I have a 1 and a 3. And the 8 and the 8 reduce, so I have a 1 and a 1. Chris, you trying it? So how about the x's? So on top I have x to the 4th, on the bottom I have x squared. Yeah, I'm going to get x squared on the top. Perfect. So those are going to cancel, and I'm going to be left with x squared. How about the y's? Y to the 5th, y squared, so I get y cubed on top. So it gets a little bit messy when we have all these canceling. So you can do it in multiple steps if you need to. So we have 1 times x squared times y cubed on the top, which becomes x squared y cubed. And on the bottom I just have 1 times 3, which is 3. That's our final answer. All right, and then on the next one, so again I have divided by, so I'm going to do times, and I'm going to flip. So if you want to start factoring, you can before you flip, or you can just flip first, or factor as you go. So let's say I flip first, and then I do times, and I'm going to put the x squared minus 16 on the top, and the x to the 4th plus 2x cubed minus 8x squared on the bottom. Try it along with me. So think, are there any GCFs that I can pull out? How do I factor these things? So let's start with the x to the 4th minus 9x squared. So the first thing we would do to factor is pull out that GCF. So we should have an x squared, and then I'm left with x squared minus 9. Okay, that will factor further. So we'll leave it for now. On the bottom, I have x squared minus 4x plus 3. So I set up my two sets of parentheses, x minus 3 and x minus 1, perfect. On the top I have x squared minus 16, it's the difference of two squares, x plus 4 and x minus 4. And on the bottom I have a GCF first, so I'm going to pull out an x squared. So I get x squared plus 2x minus 8. So right now there's only one thing that's canceling. The x squared, right? I recommend using colors too on your homework. It helps. Color pencils. So now we can factor those, the x squared minus 9 and that x squared minus 2x minus 8. So let's factor those. So x squared minus 9, all of you should know how to factor that. It's the difference two squares. X plus 3 times x minus 3, which is going to give us the x minus 3 that cancels with the bottom, right? And then I have that x plus 4, x minus 4, so when I'm factoring the bottom, I'm going to have my x, and I'm probably going to have a 4, I would guess. So 4 and 2. Our outer and inner need to combine to be positive 2. So I need a plus with the 4 and a minus with the 2. So now I start canceling, the fun part, right? X plus 4 and x plus 4 cancel. X minus 3 and x minus 3 cancel. But unfortunately, this one doesn't go all the way. I mean, there's nothing else that it does. I like when it goes like all the way down and it's like 1/3. You're like, whoa, that worked out, right? So this one doesn't go much further. So we're going to leave it as x plus 3 times x minus 4 all over x minus 1 times x minus 2. So we just leave it like that. You don't have to multiply it out. Because if you make a mistake, we don't want to make a mistake in foiling it out, right? Nope, you actually can't. Yeah, they would have to be exactly the same in order to simplify. And if you get confused, you can always plug in a number. I like plugging in 7. So I'm like, okay, what if I had 7 there? 7 minus 4 would be 3. 7 minus 2 would be 5. Can you reduce out 3/5 anymore? No. So that's one way to check, kind of, if you can simplify it. All right, we good so far? You guys got it? All right. Let's try the next one. Yeah, I kind of like, yeah, that's a good one to plug in. Because what if you had like 6 that you plugged in and then they have an even factor in common? Yeah. All right. Maybe, yeah, 1 would probably work. You guys want to try the next 2? See how you do? All right, try them. We'll see. All right, so the first one, so we're going to pull out the 5 first. So you guys should have 5 times x plus 5. And on the bottom, you should have 4 times x minus 5. Let's see, so negative 4 times x plus 5. That would be negative 4x minus 20. So we didn't actually have negative 4x, did we? So I think you can't do that. All right, so then on the next part, it's divided by. So I'm going to do this step in 1. I'm going to flip it. So I'm going to have 12x on top, and then I'm going to factor the bottom. So I had x squared minus 25, which is going to be x plus 5 times x minus 5. Now I start reducing. So I have an x plus 5 and an x plus 5 that reduce. I have a 12 and a 4 that reduce to 3 and a 1. But there's really nothing else I can cancel because I have this x minus 5 and this x minus 5, but one of them's not on top and one of them's, you know, like on top and bottom, right? They're both on the bottom. So we can't reduce those out, okay? So that means our final answer should be 15, right? 5 times 3, x all over x minus 5 times itself. So you could get fancy and you could say x minus 5 squared if you want to. Or just write x minus 5 times x minus 5. All right, did anybody get that? Yeah, several of you guys, good. All right, so the next one. So I'm going to pull out the 7, and when I do, I have x plus 2. And on the bottom, I have x cubed minus 8. Uh-oh, that's the cubes thing. So I'm going to factor into x minus 2 times x squared plus 2x plus 4. Did you guys factor that correctly? So then I'm going to flip the other side. So I'm going to have x squared minus 4 factors into x plus 2 times x minus 2. And the denominator factors with a GCF into negative 2 times x plus 2. Okay, so those should be your factorings on all of them. So check your factoring. Make sure you had it correct. Negative 2 times x plus 2. Because it was coming from here. You're pulling out the GCF. right, now we start canceling. So we know that we have the x plus 2 in common on top and bottom. We have an x minus 2 in common, but there's really nothing else. So our final answer should look like 7 times x plus 2 over negative 2 times x squared plus 2x plus 4. Did anybody get those ones all the way correct? Did you guys get it? Good. Oh, I didn't put a negative. Oh, man. So let's put the negative. It can go on the top or it can go on the bottom. It doesn't matter. All right, does this make sense? You guys get it? All right, so we're going to stop there for today. So we're breaking up this section a little bit. I'll do the next part tomorrow.